All right, let's look at this optimization problem. This is kind of a classic problem, relatively simple, but it does have an element that makes it a little complicated. We're going to use a graphing calculator to solve this one, and I'm going to show you how to do that in just a couple minutes. But here's what the question says. It says, which point on the graph of y equals x squared is closest to the point 3, 4? And so this word closest, what does the word closest mean? Well, closest, when you're trying to find out what thing is closest to something else, what you're talking about here is, let's see, closest. The word closest means minimum distance. So, when one thing has a smaller distance between, so if we have, for example, say that we have this point, and then we have this green point, and then we have this red point, and then we have this blue point. Which of these 3 points is closest to the black point, right? Got this green point, the blue point, and the red point. Well, it's obvious that the blue point is the closest dot. The reason it is the closest dot is because the distance between the blue dot and the black dot is shorter than the distance between the green dot and the black dot, and certainly shorter than the distance between the red dot and the black dot. That line between the blue dot and the black dot is shorter. It is a minimized distance. So when we say closest, what we're talking about is doing a minimum on the distance formula. And in the previous video, I already showed you that the distance formula is equal to the square root of x minus x1 squared plus y minus y1 squared, where x1 and y1 are actual values. And so what we're going to do here in this problem is we're going to put the point 3, 4 in for x and y. So it'll say x minus 3 squared plus y minus 4 squared, okay? So this is a minimum distance. We're trying to minimize the distance formula. But the problem here is, even though we only have one output value, even after we put a 3 here and a 4 here, we're still going to have 2 input variables. And therefore, we got to figure out what to do about these 2 input variables. And so the thing that we're going to do about it is the fact that if you look in the question, it says which point on the graph of, look, y equals x squared. There we go. We have a relationship between the x and the y, and so that's what we can put into this formula. The problem is that finding the derivative of this is going to be it's going to be annoying. Okay, so what we're going to do is instead, I'm going to show you how to do it on a graphing calculator where you actually don't have to find the derivative at all. I can show you how to find the derivative on the calculator, and overall, every one of these techniques in its own way is cheating, but graphing calculators are a tool, they're a useful tool, and it would be good for you to know how to use them. So right now, we're going to break for a second, or for a few minutes, and I'm going to show you how to use a graphing calculator to identify the minimum of a function. So what I'm going to do in this video is I'm going to show you how to use the TI-84 to identify a minimum point on a graph. Okay, now this can be very useful when you have difficulty finding the derivative of a function, but you still want to find the minimum point. So we've got this crazy looking function here. We've got f of x is equal to x times e to the power of sine of x squared. Now we could find the derivative of it. It's a little crazy, and we have a graphing calculator. So instead of finding the derivative of f of x and then finding the zeros of the derivative, what we're going to do instead is we're just going to key the function itself in, and then, oh, I forgot something. Let me key on here. On the interval from 1 up to 2. So let's say only between 1 and 2. Okay, so I'm going to key in x times e to the power of sine of x squared. I'm going to close that parenthesis, and then I'm going to hit graph. We'll see what happens. And sure enough, we got a crazy looking function. All right, somewhere in here is 1 and 2. And so what I'm going to do is I'm actually going to zoom in here between 1 and 2, or I'll go to, let's see here. Let's go to Window, and we'll set X min, and we'll make the minimum. Let's make it maybe 0 instead. And then the maximum, instead of 2, we'll make it 3, but we'll only go between 1 and 2. Now we'll hit graph. Now look, it's kind of zooming in. There we go. Okay, and so now we want to find this low point right here. We want to know what the minimum value is at this low point. Like I said, normally what we would do is we would simply find the derivative and then identify the 0 of the derivative, which would be somewhere around here. The derivative would be crossing the x-axis somewhere around this x value. How do I know that? Because the slope, it's a minimum point, and at minimum points, the slope is always equal to 0. So, assuming it's differentiable, which in this case it is. So, what I'm going to show you is that this calculator can find the minimum point without finding the derivative. Instead, what we're going to do is we're going to hit second and then trace, which will again give us the calculate menu. Now, you're used to going to this option, the 0 option. But instead of going to the 0 option, we're going to go to the next option, which says minimum. And the minimum feature basically goes straight to a minimum value on an interval. If you like create an interval between this number and this number, between this number and this number, in this case it's between 1 and 2, it'll find the lowest point between those two values. So then we will hit option 3, and then it says left bound. Okay, well, when it says left bound, what I would do if I were you is I would go close to wherever the minimum point is, and then go left just a little bit so that you're a little bit above, and press enter. Then it says right bound, so now we'll go back to the minimum, and from the minimum we'll go to the right just a little bit, and then press enter. And so now it's only going to look, the calculator's only going to look in this little interim period for the low point, and so it's going to get this little low point here. Okay, I think I meant to make this between 1 and 3 because here's 2 and this is beyond 2. So we're going to instead say between 1 and 2. So now when we press enter, it's going to find, there we go, the minimum point is 2.1455928. Okay, and so long as that number is on the interval that you're looking for, which it is because we're looking for the interval 1 to 3, and 2.1455928 is on the interval from 1 to 3. So we have found this low point between 1 and 3. Okay, that's all I wanted to show you how to do. So now you should practice using this feature for the kinds of problems that we're doing right now. All right, now that you know how to use a graphing calculator to find the minimum of a function, we are going to go ahead and solve this problem, which point on the graph is closest to the point 3, 4. Now understand, it says which point on the graph of y equals x squared. So our answer needs to be an x and a y coordinate. So that's what we're going for here. Okay, so let's erase this. We know we're going to minimize distance. Here's our distance formula. So step 1 is identify a formula for what is being maximized or minimized. Distance is being minimized, so we need a formula for distance. We have a formula for distance. Step 2, substitute expressions and values in for variables and constants so that a single input variable remains. Well, we're going to do both. We've got variables and we have constants. This x1, that's a constant. This y1, that's a constant. Then we have x and y, and we're going to substitute, because we have y equals x squared, we're going to replace y with x squared. And this is what we're going to have. Distance is equal to the square root of x minus, and then our x1 is 3. Our point, this is an x and this is a y, right? This is x1 and that's y1. So x1 is going to be 3 squared plus, instead of y, we're not going to put y in, we're going to put in x squared. So we have x squared minus, and instead of y1, we're going to put in the y value 4. X squared minus 4. There we go. And so this is now our distance formula, and this is what we want to minimize. Now, in step 3, it says identify the interval of input values. Okay, well, here's what's important. It's important to consider that this is a radical. Therefore, there could be, oh, this is supposed to be squared. There could be a value that we could put in for x that if it causes what is under the radical to be negative, then we can't do that because we can't take the square root of a negative value, right? Except that note that this is x minus 3 squared, so this is always going to be positive, and this is x squared minus 4 squared, so this is always going to be positive. So we're always adding a positive value plus a positive value, or we're adding 0 plus 0, which could happen too. But anyway, the point is that this can never be negative, and that's good, so we don't have to worry about it. So in 3, there is no interval of input values that we have to worry about. So lastly, we're going to optimize the function using the procedure from optimization 1. We're actually not going to do step 4. In this case, we're going to use the TI-84 calculator to find the minimum value instead of using the optimization procedure. So if you think about what we just did on my computer, I showed you how to identify the minimum value and the maximum value on a TI-84. If you'll recall, the first step is to enter not the derivative, enter the function that you have into y1. So we're going to go to y equals, we're in y1, and we're going to key in the square root of, so I'm going to hit second and then square root, so we've got a square root. And now I'm going to key in x minus, parenthesis, x minus 3, and then we're going to close the parenthesis, and then it's squared. See? We want it to look just like this, x minus 3, then squared. So you see, that's a good start right there. Then plus, and then we're going to open a parenthesis again, put x squared, minus 4, close parenthesis, squared. You see? There you go, it looks just like the problem there. Okay, and now we're going to hit graph. When we hit graph, and I need to hit zoom 6 so I can get the regular, whoops, wrong button, zoom 6. All right, and now it's going to draw the graph. You're going to see here, there we go. Now, do you see the low point right here? That is the minimum that we're looking for. So to find the minimum, we're going to hit second trace, which will give us the calculate menu, and we're going to select option 3, which says minimum. Enter. Then it says left bound. So we're going to move the cursor until it's just to the left of the low point. Left, press enter. Then it says right bound. We're going to go to the other side of the low point. Press enter. Then when it says guess, we're just going to press enter. Now it's going to tell us that the low point is at x equals 2.0565. And look, it actually gives us the output value. The output value is 0.97. Except, here's the thing. That is the output value on the distance. That's not the output value on y equals x squared. We want the point on y equals x squared. So we'll take the x value, which is, so this is optimized, or minimized, sorry, the minimum of the distance, all right, is minimized when x is equal to 2.056544. That's the x value. Now, to find the point on the graph of y equals x squared that has this x value, then we're going to plug this x value into x squared. So y is going to be, so x is equal to 2.0565, and y is equal to, so all we got to do is plug this number in here, so just square it. So I'm going to go second quit, 2.056544 squared, and that gives me approximately 4.2294. So this is the point, 2.0565, comma, 4.2294. This is the point on the graph of x squared that is closest to the point 34. Okay? Let's do another problem just like this. All right, it says which point on the graph of y equals sine of x is closest to the point 4, 7. Again, we're minimizing distance because it says closest to. So we're going to minimize the distance formula. Distance is the square root of x minus x1 squared plus y minus y1 squared. We're going to plug the point 4, 7, 4 in for x1, 7 in for y2. And where the y is, we're going to put in sine of x because y is equal to sine of x. So our distance formula is the square root of x minus 4 squared, 4, plus, instead of a y, we're going to put in sine of x, minus, instead of y1, we're going to put in 7 squared. This is the square root all the way over. We want to minimize this formula, and we're going to do it in the graphing calculator. So we're going to grab this, we're going to go to y equals, we're going to clear it out. We're going to key in exactly what we see right there. Okay, we're putting in, let's see, square root of x minus 4 squared. Okay, so square root of, parenthesis, x minus 4, close parenthesis, squared, plus, open parenthesis, sine of x. And then I have to close a parenthesis. You can see the sine of x actually has a parenthesis. I put the x in, close the parenthesis, sine of x. Then I'm going to put minus 7. You got to make sure you close that parenthesis on sine of x, otherwise it's going to think it's sine of x minus 7, which it's not. Okay? So then minus 7, then close a parenthesis again. Here's what I mean, is that these calculators require you, when you push the sine button, they open a parenthesis. You need to put in the x and then close that parenthesis. That's what you have to put in. All right, then minus 7, close parenthesis, and then we're going to square that. Okay, and now we've entered the whole thing. Now we're going to hit graph. This is what it looks like. All right, looks a little crazy there, but it looks like we got a low point right here. Okay, and so now we're going to hit second and then trace to get the calculate menu. We're going to select option 3, which is minimum. And then it says left bound. We're going to choose something left of here, which is, let's say, here, if we go to that, the minimum point, we want to be to the left, press enter. Now we want to go over to the right, it says right bound. Now we're going over to the right, enter. Now we'll press enter again. And it's 1.920946. So this is minimized at x equals 1.920946. 0946. So now I have to plug this x into sine of x. So I'm going to do sine of this number. So I'll exit and I'll do sine of 1.920946. Press enter and the output value is 0.9393. So the closest point is 1.92096, comma 0.93. Actually, I only need 4 decimals on this one over here. See, on final answers, I usually only go to 4 decimal places. On interim answers, I try to go out to 6. So 0.9393. There we go. And this point on sine of x is the point that is closest to the 0.47. Okay? All right, let's do one more of these. All right, let's see what we got here. Which point on the graph of y equals e to the x power is closest to the 0.68. So closest means minimize the distance. So we're going to use the distance formula, and we're going to fill in distance is equal to the square root of parenthesis x minus, for x1 we'll put in 6, close parenthesis and square, plus open parenthesis. Instead of the y, we'll put y is equal to e to the x, so we'll put in e to the x power to substitute in for y. Then we'll put minus, and then y1 is 8. The y value is 8 squared. So we now have a formula that has one output value and one input value, x here and x here, but we're only plugging x's in. Okay? Remember, e is a constant, a mathematical constant. It's not a variable. Okay? So now we want to minimize this formula. So we're going to go to the calculator. We'll clear this out. We're going to key in the square root of, see, we got parenthesis, x minus 6, close parenthesis squared, so parenthesis, x minus 6, close parenthesis squared. Then we're going to go plus parenthesis, right? Then we're putting in e to the x, so e to the x power, minus 8, close parenthesis, squared. Close parenthesis squared, and then we're going to graph it. See what it looks like. There it is. Oh, there's a low point. Look at that. See that low point right there? So we're going to go second trace. Go to the calculate menu, choose option 3, enter. And it says left bound. So we're going to go to the low point there. We want to go left of it, press enter, then right bound. We want to go to the right side of it, press enter, then guess, we'll just press enter, and there it is. See the cursor down there? It says it's x equals 2.1349961. Okay? All right, so is minimized at x equals 2.134996. There we go. So we got the x value. Now we just need to plug the x value into e to the x. And I'll just go, so e to the power of 2.134996. So we're plugging that number in to get the y value. E, let's see here, e to the power of 2.134996 is approximately 8.457. And then there's a 0, so I'll just stop here. So the point on the graph of y equals e to the x that is closest to the 0.68 is the point 2.135, comma, 8.457. There we go. That point is close. That is the closest point. There's lots of great reasons in this world why you would want to know the closest point between a path and a point. Okay, it's probably relevant in space travel and probably engineering as well. Okay. All right, so this is a very common problem. I'm definitely going to give you at least one of these on the quiz, and I'm definitely going to give you at least one of these on the test. So make sure that you know how to do a minimum distance problem. Now we're going to move on to a couple other very common problems in optimization.